NASA's Pioneer 7 was the fourth spacecraft to be launched as part of the Pioneer program. It was launched on August 17, 1966, from Cape Canaveral Air Force Station in Florida, United States, aboard an Atlas Agena D rocket. Pioneer 7 was a small, unmanned spacecraft designed to explore the space between the Earth and the Sun. One of the primary objectives of Pioneer 7 was to study the solar wind, a stream of charged particles that flows continuously from the Sun. The spacecraft carried instruments to measure the intensity and direction of the solar wind, as well as its temperature and density. These measurements provided valuable information about the nature of the solar wind and its interaction with the Earth's magnetic field. Another objective of Pioneer 7 was to study the interplanetary magnetic field. The spacecraft carried a magnetometer to measure the strength and direction of the magnetic field in space. This data helped scientists understand how the Sun's magnetic field affects the interplanetary environment. Pioneer 7 was also equipped with instruments to measure cosmic rays, high-energy particles that originate outside the solar system. By studying cosmic rays, scientists can learn more about the structure of the universe and the processes that create and accelerate these particles. The spacecraft was designed to operate for 1 year, but it exceeded expectations and continued to return data for over 11 years. During its mission, Pioneer 7 set several records, including the longest operating spacecraft and the farthest distance from Earth at which a spacecraft had made measurements. In addition to its scientific objectives, Pioneer 7 also served as a test bed for new technologies and techniques that would later be used in other space missions. For example, the spacecraft was the first to use a solid-state recorder to store data, which allowed it to transmit more data than previous spacecraft. Pioneer 7 was also notable for its trajectory, which took it on a looping path around the Sun that brought it closer to Earth every 6 years. This allowed scientists to use the spacecraft to study the interplanetary medium at different distances from the Sun and to compare data over long periods of time. Despite its many successes, Pioneer 7 did experience some technical difficulties during its mission. In 1978, a malfunction in the spacecraft's power system caused it to lose contact with Earth for several weeks. However, NASA engineers were eventually able to restore communication with the spacecraft and continue its mission. Pioneer 7 was ultimately retired in 1995, after over 28 years in space. During its mission, the spacecraft provided valuable data that helped scientists better understand the nature of the solar wind, the interplanetary environment, and the structure of the universe. Its legacy continues to influence future space exploration missions and scientific research. In recognition of its contributions to science and space exploration, Pioneer 7 was designated a National Historic Landmark in 1989. The spacecraft's scientific instruments and other artifacts are now on display at the Smithsonian National Air and Space Museum in Washington, D.C. Pioneer 7 was one of several spacecraft in the Pioneer program, which was designed to explore the space between the Earth and the Sun. The program included a total of 9 missions, including Pioneer 6, which was launched just 2 days before Pioneer 7. The Pioneer program was notable for its many scientific achievements, including the first direct measurements of the solar wind and the first close-up images of Jupiter. The program also pioneered many new technologies and techniques that would later be used in other space missions. Despite its many successes, the Pioneer program was not without its controversies. In the 1970s, some scientists raised concerns about the possibility of the Pioneer spacecraft carrying life to other planets. However, subsequent studies found no evidence of contamination or any negative effects on the interplanetary environment. Today, the legacy of the Pioneer program lives on through its many scientific achievements and contributions to space exploration. The program paved the way for future missions to explore the outer planets and the depths of space beyond our solar system. One of the most important contributions of the Pioneer program was its role in laying the groundwork for the Voyager missions. The Voyager spacecraft, launched in 1977, built on the successes of the Pioneer program and provided unprecedented views of the outer planets and their moons. In addition to its scientific achievements, the Pioneer program also had a significant impact on the public's perception of space exploration. The program generated widespread interest and excitement about space exploration, inspiring a new generation of scientists and engineers to pursue careers in the field. The Pioneer program also helped to establish the United States as a leader in space exploration and technology. Its many achievements demonstrated the capabilities of American scientists and engineers and cemented the country's reputation as a leader in the field of space exploration. Today, the legacy of the Pioneer program lives on through its many scientific discoveries and contributions to our understanding of the universe. The program's achievements continue to inspire new generations of scientists and engineers to explore the mysteries of space and to push the boundaries of what is possible. As we look to the future of space exploration, it is clear that the lessons and achievements of the Pioneer program will continue to play a critical role. From its pioneering use of new technologies to its groundbreaking scientific discoveries, the program remains an important part of the history and future of space exploration. Specifically, the data and insights gathered by Pioneer 7 continue to inform scientific research today. For example, the spacecraft's measurements of the interplanetary magnetic field have helped scientists better understand the complex interactions between the Sun and the Earth's magnetic field, which have important implications for space weather and the safety of astronauts and spacecraft. Pioneer 7 also provided important data on the heliosphere, the region of space that is dominated by the Sun's influence. By studying the heliosphere, scientists can better understand the fundamental processes that govern our solar system and its interaction with the wider universe. The spacecraft's longevity in space also allowed scientists to study the effects of long-term exposure to the space environment on spacecraft systems and components. This knowledge has been invaluable in designing future spacecraft and in developing strategies to mitigate the effects of radiation and other hazards of space travel. The Pioneer program also had a significant impact on the development of space exploration policy and international cooperation. The program's successes and achievements helped to cement the importance of space exploration as a scientific and strategic priority for the United States and other nations around the world. Moreover, the program served as a model for international collaboration in space exploration. Pioneer 6 and 7 were launched in cooperation with the Soviet Union, and the data collected by both spacecraft were shared between the two nations. This collaboration laid the foundation for future joint missions and partnerships in space exploration. Today, the Pioneer program remains an important part of the history and legacy of space exploration. Its many achievements and contributions continue to inspire scientists, engineers, and policymakers around the world to push the boundaries of what is possible and to explore the mysteries of the universe. In recognition of the program's contributions to space exploration, NASA established the Pioneer Award in 1988. The award is presented to individuals or groups who have made significant contributions to the exploration of space and who have demonstrated a commitment to advancing the frontiers of human knowledge. The Pioneer program also serves as a reminder of the importance of scientific exploration and discovery. By pushing the boundaries of what is possible and pursuing new knowledge and understanding, we can unlock the secrets of the universe and achieve new heights in space exploration. As we continue to explore the depths of space and expand our understanding of the universe, the lessons and achievements of the Pioneer program will continue to guide and inspire us. From its pioneering use of new technologies to its groundbreaking scientific discoveries, the program remains a shining example of the human spirit of exploration and discovery. One of the notable accomplishments of Pioneer 7 was the discovery of the Pioneer anomaly. This anomaly referred to the unexpected deceleration in the spacecraft's trajectory as it traveled further away from the Sun. While the cause of this phenomenon remains a topic of ongoing research and debate, it has led to new insights into the behavior of spacecraft in the outer reaches of the solar system. Pioneer 7 was also notable for its role in studying the Sun and its influence on the Earth's magnetic field. By studying the solar wind, the spacecraft helped to advance our understanding of the Sun's activity and its impact on our planet. In addition to its scientific achievements, Pioneer 7 was also a technical marvel. The spacecraft was equipped with a range of cutting-edge technologies, including a solar pressure sensor that measured the pressure exerted by sunlight on the spacecraft's solar panels. This data was used to help guide the spacecraft's trajectory and navigate through space. Pioneer 7 was also one of the first spacecraft to use a radioisotope thermoelectric generator, RTG, to generate power. This technology, which uses the heat generated by the radioactive decay of plutonium-238 to produce electricity, allowed the spacecraft to operate for over 11 years, long after its original mission had ended. Overall, Pioneer 7 was a groundbreaking mission that helped to pave the way for future space exploration and scientific research. Its many achievements and contributions continue to inspire scientists, engineers, and explorers around the world to pursue new discoveries and push the boundaries of what is possible. As we look to the future of space exploration, it is clear that the lessons and achievements of the Pioneer program will continue to play a critical role in shaping our understanding of the universe and our place in it. From its pioneering use of new technologies to its groundbreaking scientific discoveries, the program remains an important part of the history and future of space exploration.